Today we are going to look at solving systems of equations by graphing and then by substitution. So first question, what is a system of equations? So a system of equations is just two or more equations of the same variables. So we could have two lines intersecting. We could have a parabola with a line. They could intersect or not intersect, all kinds of things. So in Algebra 2, we're not just looking at linear systems, we also look at systems with curves. But today, we are specifically looking at only linear systems. So we're reviewing a concept from Algebra 1. And then what does it mean to be a solution for a system? So the solution for the system would be where in this case, two equations intersect. So you could have 3, 4, 5, 6 equations in a system, but wherever all of them intersect, so in this case, these green points right here, those would be points that both the parabola and the line have in common, so they would be considered the solution. With the two intersecting lines, that's the place at which they intersect, so this ordered pair would be considered the solution. So then we have different types of systems that we could graph. So as I was mentioning, we had two lines that intersect. So number of solutions with intersecting lines would be one solution. The intersecting lines would look like, you could have one line here, assuming that there's arrows on them. And then we could have a second line here. So their one solution would be right here where they intersect. So these are called intersecting lines. So if our lines don't intersect, then they could be parallel. So we could have parallel lines. There are parallel lines in the word parallel. And parallel lines would look like they might look like that. And so as you can see, these two lines do not intersect each other, so since they don't intersect each other, there is no solution. Then we could have what are called coinciding lines. Coinciding lines would look like let's see, let me take that one out. I don't like that one. Let's try that again. So as you can see, I've got the same line intersecting the same line. So the two lines touch each other in an infinite number of times because we assume that there's arrows on both ends. So since they touch each other, they intersect each other an infinite number of times, there are infinitely many solutions. So all of that should be a review from Algebra 1. What's not a review is this terminology here. We can identify a system as being consistent or inconsistent and dependent or independent. For a solution to be, let me move this out of my way, for a solution to be considered consistent, well, for a solution to be considered dependent or independent, right here, this requires a solution. So if I can fit that in there, requires a solution. So let me maybe change the color here. So those two, dependent and independent, require a solution. So that means that parallel lines which have no solution could not be dependent or independent. All types of linear equations, whether one solution, no solution, or infinitely many, can be listed as consistent or inconsistent. So let's start there. If a system is consistent, it means it has at least one solution. The key word here is at least one solution. So that means that the lines that meet that standard would be intersecting lines, and then coinciding. Both intersecting and coinciding lines have at least one solution. Intersecting has one, coinciding infinitely many. Then let's skip all the way down to inconsistent. Inconsistent means that there is no solution. So the key phrase here, or word, is no solution. The only line, or the only system that matches that, would be parallel lines. So a system is either consistent or inconsistent based upon the number of solutions. If it has any kind of solution, it's consistent. If it has no solution, it's inconsistent. So then let's talk about dependent and independent. For a solution to be independent, it must have one unique solution. Keyword here is unique and one. So the only system that has one solution, and if you're unique, you stand out, you are different from everybody else. So the only system that matches this is your intersecting lines. It is the only one with one solution, period. If you are dependent, or if a system is dependent, then it has more than one solution. And so the only one that matches that is coinciding. So let's put it all together. We'll look at the next slide. So in this slide, everything is put together. And so this is a slide that you might want to use for study purposes. So lines that intersect would look like this. They have one solution, and so because they have a solution, they are consistent. Because their solution is unique and there's only one of them, they are considered independent. Parallel lines would look like this. Parallel lines, because they have no solution, are called inconsistent. And because they have no solution, they can be neither independent nor dependent. Coinciding lines, remember, are the same line intersecting itself. Whoops, I did a terrible job intersecting it. Let's try that again. One more time. There we go, that's much better. All right, so coinciding lines have an infinitely many number of solutions. Because they have a solution, they're considered consistent, but because they have more than one solution, they are dependent. So in this slide, we are going to graph our first system. And you can ignore the calculator steps because we won't be using our calculator, but there they are here at the bottom of the screen. We are going to be doing it by hand. So let's start off with example 1. The very first thing that you need to do is you need to have your equations in slope-intercept form, y equals mx plus b. And as you can see, both equations are solved for y, so we're ready to go from there. All right, so let's start with the first line, and I'm going to identify the y-intercepts. So the y-intercept is -2 because that's your constant, and your slope is the coefficient of x. So my slope is -1/2, so you have to put the negative either in the top or the bottom. I'm going to start with the top, and the bottom is positive. Or, remember, you can change both signs, so because you have to look at slope in two different directions. So -1 becomes a +1, and +2 becomes a -2. So both fractions are equal to -1/2. So I'm going to start my graph at -2 on the y-axis. And then I am going to stair-step my slope of a negative rise, which is down 1, and a positive run of 2, which is right 2. So I'm going to go down 1 to the right 2, plot a point. Down 1 to the right 2, plot a point. Then I'm going to go in the other direction. A +1 rise is up 1, and a -2 run is left 2. So then I'll go up 1 to the left 2, up 1 to the left 2. So here we go. So then I'm going to connect these with a straight edge, which you need to use a straight edge because we're trying to solve a system by graphing it, and you need to be as accurate as possible. Okay, and then we will assume, let's see, I'm going to put arrow on this line and an arrow on this line. All right, so then let's look at our second equation. So this is my y-intercept, and this is my slope. So I'm going to start graphing at my y-intercept, which is +2, and then my slope is -3 over +2, or change both signs, +3 over -2. So I'm going to go down 3 to the right 2, up 3 to the left 2. So let's start with this one. So if I go down 3, 1, 2, 3, I'm going to go to the right 2. Down 1, 2, 3, and to the right 2. And you'll see that this is where they intersect. So here we go. And then I'm going to connect with a straight edge. And put arrows on my lines. Okay, so now our solution is right here, and all you need to do is name that ordered pair. So its x value is, the numbers are off a little bit here, so this is 0, so 1, 2, 3, 4 is where that x value is, and the y value is -4. So our solution is +4, -4. And it's as simple as that. Let's look at another one. Let's not forget to name this system. We have intersecting lines with one solution, so because there is a solution, it is consistent. And because that one solution is unique, it is independent. So I'm going to make this one bigger. Move it over just a smidge. Okay, so for the first equation, once again, you've got both equations solved for y for you. So I want you to pause the video, and I want you to graph these on your own, and then check your answers, restart the video. So I'm going to quietly just do the work, because I'm assuming at this point you've restarted the video. So here we go. Now on this one, remember you're changing both signs because both were positive, so then both become negative. Two negatives make a positive. Okay, so then I'm going to graph the second one. Now on this one, remember your coefficient is -1, so we're going to put -1 over 1. And then change both signs. And then I'm going to connect with a straight edge. And as you can see, this is the solution. So that has an x value of +3 and a y value of -2. So again, from here, your x value is +3, y value -2. So let's discuss the name of this system. So because we have intersecting lines, there is one solution. So it is consistent because it has a solution. And it has a unique solution, so it is independent. Now in this example, number 3, you do not have your equation solved for y. So that is going to be your struggle for this one. So I'm going to solve this equation for y. So I'm going to do my work down here on the bottom. So let me start with the first equation. So I've got x minus 2y equals 0. So use your equation solving skills. We want to solve for y. So this is the term that has y in it. The negative belongs to the 2y. So the x is positive. So to move a positive x, we are going to subtract x. Bring down the negative with the 2y equals, and then you have a negative x. Now you could put this +0 here if you wanted to, right here, so that you could see what the y-intercept is going to be, but it's really not part of the equation. But since we're using it for graphing, I'm going to go ahead and put it in there for some of you so you can easily see what's going on. So then y is being multiplied by -2, so we need to divide by -2, and every term gets divided by -2. So we get y equals, and if you take the x out of this fraction, number 1, the two negatives become a positive. If I take this x out of the fraction, I have a 1 in the numerator. So I have 1 over 2, because those negatives canceled, x, and then 0 divided by -2 is still 0. And so since that's not really part of the equation, I'm going to still keep it in green. So as you can see, I don't really have a constant here, and so that is your y-intercept. So if you don't have anything added or subtracted to your x term, your your y-intercept is 0. So we're going to intersect the y-axis right there at the origin. And then my slope is +1 over 2 or -1 over -2, because you got to change both signs. So I am going to go up 1 to the right 2 and then down 1 to the left 2. and connect that with a straight edge. And put arrows on your line. All right, let's look at the second one. So I'm going to take the second equation, which is x plus y equals 6, and I'm going to solve that for y. To get the y by itself, the x is positive, so we will subtract x. We are trying to get it into slope-intercept form, so the x needs to come first. So y equals negative x and a positive 6. So my constant is 6, so my y-intercept is 6. So that means we're going to start all the way up here. Oop, that would not be 5. So I'm going to have to go 1 unit off of my grid, which is fine. You can manage that. And then our coefficient in front of x is a negative, which implies that there is a negative 1 in front right here. So that means my slope is negative 1. Because it's not a fraction, I'm going to put it over 1, or change both signs, positive 1 over negative 1. So from that point, my only option, because I'm all the way up here, I can only go down. So my only option is this slope here, down 1 to the right 1. So down 1 to the right 1, down 1 to the right, and so forth. So I'm just going to stair step that slope all the way down. Here we go. And I'm going to connect those with a straight edge. And put arrows. So our solution is right here. And the x value is 1, 2, 3, 4, so positive 4. The y value is positive 2. So 4, 2. Let's talk about the name of this system. So because it has a solution, it is consistent. And because we have one unique solution, it is independent. So for this example, I want you to pause the video and I want you to graph this on your own, and I want you to name the system on your own as well, and then replay it and check your answers. So I will just, as quietly as possible, do my thing. So I'm assuming at this point you have gone ahead and graphed yours and you're just checking it. So here we go. Don't forget to divide everything by 4. Taking the x out of the fraction, you have a negative up top, which means you have a negative 1 and a 4 in the denominator. X, 20 divided by 4 is 5. So my y-intercept is 5. And my slope is negative 1 over 4, or 1 over negative 4. So I start off at 5 on the y-axis, and I am going to go down 1 to the right 4. Down 1 to the right 4. Then I'm going to go up 1, but to the left 4. And so I will connect those with a straight edge. And put arrows on. Oh, that's a sad little arrow. Okay, then the second equation. Don't forget to divide everything by the -4, including that 8. The two negatives make a positive, and then you have to reduce 6/4. 2 will divide into both 6 and 4, so 6 divided by 2 is 3. 4 divided by 2 is 2x. Then a positive divided by a negative is a negative. 8 divided by 4 is not 8. Let's try that one more time. 8 divided by 4 is 2. So, oh goodness, that is not going to work. I guess I'm not going to change that. So my y-intercept is -2, and my slope is 3/2, or -3 over -2. So let's start at the y-intercept at -2. And then I'm going to go up 3 to the right 2. Up 3 to the right 2. And they don't always intersect in a nice happy place. And I'm going down 3 to the left 2. Okay, so let me connect those. Okay, put arrows on the ends. And there we go. So our solution is here. And if you name the x and y value, the x value is 4, y value is 4. So that means our solution is 4, 4. And once again, we have intersecting lines with one solution. So it is consistent and independent. Now that's enough of solving systems by graphing. Let's move on to a different concept, which is solving systems by substitution. So as you can see here, I've got all of the steps that you need in order to solve a system by substitution. I will only solve a system by substitution if I have one or more of these variable terms here that has a coefficient of 1 or -1. If none of these have a coefficient of 1 or -1, I would not use substitution. There's a far better way, which we will look at in the next video. But because this has a coefficient of 1, your first job is to choose one variable to solve for in one equation. So sometimes you have more than one choice because maybe this has a coefficient of 1 and this does. So then you could choose, to solve this equation for the x if it had a coefficient of 1, and this equation for y. But since this is the only variable term that has a coefficient of 1, I'm going to solve the second equation for the y. So our first step, I'm going to take 2x plus y and solve it for y. So all I have to do is move the x by subtracting 2x. Because we're not graphing, you don't have to have this in slope-intercept form. We just happen to be solving for y. So you can write it as 14 minus 2x. Then our second step says plug the first equation into the second. So you have to take your answer that you got when you solved the one equation for the variable. So this is the value of y, 14 minus 2x. That means that this y equals 14 minus 2x and this y equals 14 minus 2x. Well, I solved this equation for the y, so I have to take this and plug it, substitute it into the other equation. If I try to substitute this into this y, all of your variables are going to drop out and you won't be able to solve anything. So you have to take the value for y and plug it into the other equation's y. Now the reason for this is because if we're trying to find a solution that these two equations have in common, our assumption is that they both have the same y and they both have the same x values. So if this y value is equal to 14 minus 2x, then this y value here should also equal 14 minus 2x. So step 2, we are going to do our first substitution. And this substitution is very similar to what we did with compositions. So I'm going to take 2x, not 2x, because that would be the wrong equation. Let's try this again. Let's take the first equation, which is 3x, plus 2, and instead of y, big parentheses, equals 24. And so this value here is going in here. So we've got 14 minus 2x. Then we're going to do the math. So you're good at solving equations, so we're going to use our algebra, and we're going to solve for x. So hopefully the fire alarm bells won't go off, but here we go. So we've got 3x, 2 times 14 is 28, 2 times negative 2x is negative 4x equals 24. Collect your like terms. 3x minus 4x is a negative 1x. Then plus your 28 equals 24. You are solving for x, so we're going to subtract 28. And we get a negative 1x equals 24 minus 28 is a negative 4. To solve for positive 1x, we're going to divide both sides by negative 1. And I get x equaling a positive 4. So that's half of my answer. So once we get one answer, we're going to solve, well, that was 2 and 3. So I guess I'll put up here that we already accomplished step 2 and 3 as we subbed and solved for the remaining variable. So then step 4, you're going to plug the answer from what we just got here into either one of these two original equations. It doesn't matter which one. You're going to put this 4 in for either this x or this x, whichever one of these two equations you think is easiest to substitute the 4 in to the x. I like the second equation. There seems to be fewer numbers. So that's what I'm going to choose to do, is plug into the second equation. So here we go. So I'm going to take 2, and instead of the x, I'm going to replace it with the 4, and then plus y equals 14. So again, what did I just do? I took this 4 and I plugged it into the x value, which was this equation here. I replaced x with 4. And here we go, do the math. 2 times 4 is 8, plus y equals 14. Solve for y, subtract 8, and then your y is equal to 6. So your very last step, and this is an important step, we're not done, you have to write the answer in terms of an ordered pair. If you forget to do this, you're going to lose points because the answer is an ordered pair. It's not a separate x and y value. So you have got to remember to rewrite it. So our x value is 4 and our y value is 6, and this is what your answer should look like. So again, since I have an answer, I know I have intersecting lines. That's the only one that gives me one unique answer. And because the lines are intersecting, I know that my system is consistent and it is independent because that answer is unique. So I don't even have to graph it to know that I have intersecting lines. All right, so now for this problem, I want you to decide on your own, are you going to solve the first equation for x or for y, or the second equation for x or for y? So pause the video and make a choice and then restart the video. So hopefully you made the decision to solve the first equation for this y because it is the only variable term out of all 4 that has a coefficient of 1 or negative 1. So that's where we're going to start. So step 1, I'm going to take the first equation, 9x minus y equals 11, and I'm going to solve for y. So the negative belongs to the y, so the 9 is positive. So to move it, I need to subtract 9x from both sides. So I get a negative y equals, and we're not graphing, so you don't have to put the x term first, so you can write it as 11 minus 9x if you wish. But we have to solve for positive 1y, and right now there's a negative 1 in front, so you have to divide every single term by that negative 1. So you get y equals negative 11 plus 9x. So this y value of negative 11 plus 9x is the value for that y and the value for that y. So then we have to take this and substitute it in either here or here, but not both. So actually I take that back. Since we solved this equation right here for the y, you have to plug it into the second equation. We don't have a choice. So your second and third step, we're going to substitute and solve. So I'm going to take the second equation because that's the leftover one. So when we have to plug it into, we don't have a choice. And we're going to take this value right here, and I'm going to put it right in here. So I get a negative 11 plus a 9x. Use your math and solve. I'm going to distribute a negative 2 into the parentheses. So I get 12x. Negative 2 times negative 11 is a positive 22. Negative 2 times 9 is a negative 18x equals 10. Collect your like terms. 12x minus 18x is negative 6x plus 22 equals 10. We are solving for x, so move the 22 by subtracting it. Negative 6x is equal to 10 minus 22 is negative 12. Divide by negative 6, and you get x is equal to a positive 2. So that's only half our answer. So then step 4, now you actually get a choice. In step 4, you can choose to plug this value in for x, either here or here, it doesn't matter which one. So I'm going to plug it in to this one. It just looks like it's less busy. So I'm going to take 9 instead of x, I'm putting in parentheses, minus y equals 11. So then this value for x is going in right here as a 2. So then 9 times 2 is 18, minus y equals 11. Solving for y, the negative belongs to the y, the 18 is positive, so we want to subtract 18 from both sides. I get negative y equals negative 7. Remember, there is a negative 1 in front of that y, so we need to divide by negative 1 to solve. And you get y equals positive 7. To finish it off, you actually have to write the answer as an ordered pair. So our x value is 2, and our y value is 7. So again, I have intersecting lines, which are consistent because we have a solution, and independent because it is a unique solution. Example 2. Now, you do this one completely on your own. I want you to stop the video and then restart it. So hopefully you're now checking your work. So I'm going to quickly go through this example and solve it. I am choosing to solve the first equation for x, and that's really the one that you needed to use because that's the only variable term that has a coefficient of 1. So step 1. So then I'm going to solve for x. So I want to move the 2y by adding 2y to both sides. So I get x equals 2y plus 4. So if x equals 2y plus 4, and I used this equation, I must plug this value in for this x here. You don't have a choice. So if you use the first equation, you have to plug it into the second. So my second equation, I'm plugging in for for x. So I've got 2 big parentheses minus 4y equals 8. So I'm going to take this value for x and substitute it in where the x is in the other equation, which is there. So this becomes 2y plus 4. And now you have one equation with one unknown. And so I guess this is step 2 and 3 because I'm going to solve. So I'm going to distribute that 2. 2 times 2y is 4y. 2 times 4 is 8. Minus 4y equals 8. Oddly enough, a weird thing happens. When you try to collect your like terms, 4y minus 4y, they just cancel out. And you have no more variable terms. So if you check all your math and make sure you did it correctly, you're like, yeah, I did it correctly. So if your variable terms drop out, you either have parallel lines or coinciding lines. Again, if your variable terms drop out, you either have parallel lines or coinciding lines. To tell which, here's what you do. You've got to write what's left over on the left, which is 8 in this case, and what's on the right, and evaluate that statement. Is this statement true or false? Well, it's true. 8 does equal 8. If you have a true statement, it means that you have a solution. And so out of those two, if you have a solution, parallel lines versus coinciding lines, then it has to be coinciding lines. So coinciding lines have, infinitely many solutions. So that is your answer. And so again, these are coinciding lines. So because they're coinciding, they have a solution, so they are consistent. Let's see if I can spell that correctly. But because they do not have a unique solution, they are dependent. Now, if you end up with a false statement, so this is totally has nothing to do with this problem. So if you have a false statement, it might look something like, oh, I don't know, 2 equals -4. Or you might have 0 equals 8. Clearly the left side does not equal the right side. That would be a false statement. So if you end up with your variable terms dropping out and the left side does not equal the right side, the only type of false statement solution that we could have would be no solution. And if you've got a system with no solution, it means that you have parallel lines. Well, parallel lines do not have a solution, so therefore they are considered inconsistent. Because they don't have a solution. And because they don't have a solution, they are neither dependent nor independent, so they are only inconsistent. That's it. Good luck with your homework. Let me know if you have any questions.